So my name is Erica Harris and I'm a data solution architect at Microsoft. I'm based in the Melbourne office, and in my role I work with our customers in Melbourne and architecting solutions, data solutions in our Azure cloud. So today we're going to be talking about some of our experiences with our enterprise customers and how we've gone about working with them to basically take an open source product and I guess get past some of the security, cultural and enterprise hurdles, process control, etc., and help them enable Hadoop in a meaningful way in their organisations.
I'm Aaron Morrison. I'm a digital advisor with Microsoft Services, working primarily with enterprise customers. So I've worked across, or together the experience between the two of us is retail customers, health industry, finance industry, telecommunications, energy utilities, and both locally and overseas as well. So we've seen quite a few of the enterprise customers. We've worked with a number of data platforms, those sort of things. So what we want to share with you today is what we've seen in enterprises, what works, some of the pitfalls, and hopefully help you accelerate your journey with regards to Hadoop, big data, and analytics within the enterprise. So hopefully we'll work through this today and you can get a few pointers. And if you don't mind, we've got a sequence of slides. So if you don't mind, we've got 15 minutes at the end of the session for questions and answers. So if you don't mind holding to then, that'd be great.
So when we're asked to come up with a session about HD Insight for Ignite, it's a really huge topic. Like, we could talk about this for days and days and days. So we basically got around a whiteboard and started looking at what are the really common themes we're seeing across our customers and started to, I guess, mind map and group them together. So the first one's around capabilities. So typically when we're asked to come and help with a big data implementation, the driver for this is not coming from IT. It's coming from marketing or one of the other business groups. And so often IT, once they start getting involved in this, there can be a little bit of resistance. And some of it's around, we've got a data warehouse, we don't need a big data platform, or we don't have big data. And I guess some of the other things is, we've got skills in this particular relational product, we don't have Hadoop skills, so what does this mean for our organisation? How are we actually going to implement and support this? And what's it actually going to do? Is it going to enable anything we can't do already? So that's the capabilities discussion. The next one's around security, and often we'll go within a customer, we'll talk about the capabilities, we'll get past all that discussion, and then the real hurdle's security, because we're looking at an open source product in an enterprise organisation. So I've worked at plenty of enterprises that wouldn't even put SQL Server into the environment until it was SP1. So we're going, here, this is an open source product, it's got incubating parts, the community all contributes to it, let's use that. So there's a bit of fear about putting something like Hadoop into an enterprise. And then just beyond that, how do we actually secure that? How do we look at our networking identity and integrate that with our existing infrastructure? And then finally, the ops guys. So how do we actually support this? How do we monitor it? How do we integrate this with our CI/CD processes? So that's what we'll cover in the third section around enterprise.
So looking at capabilities of big data and more focusing on the big data side of things and the question of big data at the moment is, why do big data? What does it enable for you? And what we want to talk about today is how big data can influence an outcome and influence decision making. So the whole purpose of big data and analytics is to derive a better outcome, derive a better decision, and assist in making better decisions and enhancing the outcome that you're looking after. And one of the examples that I'd like to share with you is we do quite a lot of analytics day to day, and analytics ourselves. And one of the examples that I want to share with you is hopefully an analogy that will allow you to understand why big data can help influence an enterprise. So if you think about getting your email on a daily basis, and there's quite a lot of material that comes through your email in terms of advertising and discount offers and those sort of things. So imagine you get an email and that email says 75% off accommodation. And it's a destination that you would like to go to for a holiday, and you think, well, looks like a great deal, but what's the catch? On its own, that piece of information isn't enough to build a holiday. So you go through the process and you have a look at, well, what are the airfares? Are the airfares going to, sort of work against me, and are they going to offset the discounts that are associated with the accommodation? What about the weather? What about tourist ratings? Things to do, attractions. So what do? You start to browse the web and you start to use various sources of data to help inform your decision. You might even go out and buy a book. So from that, you start to look at things like ratings, star ratings. You start to look at weather. What's the average weather for this month when the discount period's on? Is it going to be hot? Is it going to be too hot? Is it an off-season? Is it in the tropics and it's monsoon season? So there's a bunch of different data sources that you're starting to look at, but it's not standard form. So as I mentioned, star ratings, temperature, averaging, variance, those sort of things. It might be textual. It might be sentiment comments that are in tourism reviews. So there are all these different types of data that you're ingesting to help you build a better outcome, which is a better holiday. So how does this all relate to big data?
So big data is not voodoo. I think sometimes it's considered a bit of a dark art. So there's the 5 V's of big data. And the first one's volume. And this is something we hear a lot. People look at their company and the data that they've got currently and they're going, we're not Facebook, we're not Twitter, we don't have that volume of data. Even in the AMA session yesterday evening, we're talking about people who are ingesting terabytes of data every hour. So when you're looking at your own data sets, you're going, look, I don't think our data's really big. But volume's just one aspect of big data. Another really key one's variety. So looking at Aaron's analogy there, we're looking at trip ratings, and so they're going to be free text information that people are typing, their reviews. And you're going to look at some of these and go, yeah, okay, that's fair. You're going to look at some of the others and go, geez, that person's just a whinger. So you're going to start making assessments about this data that you're seeing. As well as that, you'll be looking at photos. You might be looking at videos of the holiday destination. So these are all different types of data, and in your mind, you're joining them together. But in a business context, we need a platform where we can start taking things like structured and unstructured data and start joining them together. And because we're getting data from external sources, we also need to understand that the schema, we don't have control over it. So we've got to be able to deal with variety. And that's where we're looking at a platform that allows schema on read rather than schema on write. The next thing's velocity. So that's the speed of the data. And these days everything's IoT, we've all got wearables, we've all got phones, we're generating data constantly. So we want a platform where we can start to capture this data and ingest it fast and maybe look at it real time, make some decisions, start rating things. Which data am I going to accept? Which data am I going to reject? Then variability. So even when I am using a particular source of data, so maybe weather data, I'm looking at BOM. So I'm getting their feed of their daily information. Next week, if they start adding another aspect of the data, the weather, I want to be able to actually take that data. I might not be ready to process it yet, but I need to start capturing everything they can give me, and then I can kind of start to integrate that with what I'm doing currently. And last thing's veracity. So when we're getting all these really unusual sources of data, how accurate or trustworthy is this data? So again, talking about those trip reviews, when I look at that, some of them are going to be in a foreign language for starters. So I'm going to have to be able to start processing those. There's going to be spelling mistakes, typos, and like I said, there's going to be some that are just garbage. There might be someone who's got a beef with a company or something, so they start writing really stupid stuff that's not even related to a review. So we need to be able to basically take this data, trustworthy, untrustworthy, and start to process it.
So how does this relate back to businesses? Well, if you have a think about it today, the data's always been there. So information has always been coming into organisations and the data's always been there. But one of the things that we have a capability of today is being able to store that data and being able to capture that data. And now we're at the stage where we need to process that data. So typically we threw data away, and that was due to storage restrictions and capacity constraints and the sheer cost of having storage solutions on-prem. Now with cloud, I guess that's a different scenario, and it allows you to store that data and do something with it. So one of the things around Hadoop is being able to, big data in general, is being able to process that data and transform it. So take that data as it is, raw data, transform it into an asset. Because in its raw state, it's meaningless. It doesn't do anything for you. But being able to transform it and turn that into an asset that's of value to you, or value to the organisation, or of value to a business unit, that's where data starts to become powerful. And that's the advantage of big data. So take the analogy that I gave you earlier of different data sources, being able to process those data sources and make a better decision. That's where data becomes an asset. It allows you to understand insights into customers. So for example, you might measure the wait time someone has in an IVR or a call management system. You might be able to have a look at the data and analyse their process as they click through a website. So which buttons did they click on, or which parts did they navigate to, and having a look at the click-through logs. You might have a look at system data, and you might have a look at the response time that a system has. Maybe relate that back to a user experience. Start to identify patterns around good user experiences or good customer experiences, negative customer experiences, and identify those things and what you can do to better change those experiences that you have with customers. It can also open up new business capabilities. So with all the data that you're collecting, whether you're generating it or collecting it from external sources, it also presents new opportunities to generate new revenue streams. So you may be able to turn that into an API or an open data service and monetize that data. So there may be someone else outside of your organisation that's actually interested in the data that you're harvesting or data that you're producing. So you can start to generate new revenue streams with what you're collecting and harvesting. As Erica mentioned earlier, it's typically not IT that's interested in the data. IT's always been interested in logs, security logs, system logs, event logs, those sort of things. But now as we're starting to open up the world of data and collect that data and start to process that data and make it valuable, it's the marketing department that's becoming very interested in the data, the finance department, strategy parts of the organisation, business operations. So it's now a data-driven world that's outside IT. And I think that's the change that we're all starting to see, is that when we start to empower other parts of the business, that's where they start to embrace this. And that's where they're starting to get involved in, well, I want to get involved in the big data game. I want to see what big data can do for me. I need the data to be able to process it. I want to make a better decision. And that's one of the key messages that we want to drive home today. Being able to make those better decisions and produce an outcome that we typically couldn't do before.
So finally, we get to Hadoop. So it's become synonymous with big data. It's not necessarily the only platform that you can use for big data, but it's probably one of the most extensible. It's a framework based on a few core products: distributed file system, MapReduce, Yarn, and then all kinds of building blocks where you can pick and choose which components suit you and your requirements. They're all around manipulating and moving data and have different use cases. So obviously, being a distributed file system, this has come out of the, we don't need a huge big piece of tin, we don't need to go start buying appliances, we can start doing this on commodity hardware in a divide and conquer kind of methodology. And because the commodity hardware is so cheap, we can just keep adding to it and adding to it, so it can grow as our business grows. So we can start off small, expand as we need to. We mentioned there's a different skill set. So in an organisation, you've typically got your people who are used to dealing with structured data. So what kind of skills do we need once we start looking at Hadoop? So obviously when we're talking about a distributed file system, a distributed compute nodes, there's a hardware component. How do we assign roles to each of these nodes? How do we wire them up together? How do we communicate between them? Luckily with the cloud, we can abstract some of that for you, and we'll get into HD Insight in a little while. On top of that, obviously we do need people who know how to manipulate, transform data. How do we get to data in a performant way? So there's still definitely that skill set, that deep knowledge. People have been working with data for years and years and years. But the other thing is the extensibility. So most of Hadoop is Java-based. So we need programmers, we need people with Java skills to be able to augment those data skills as well. And then, of course, there's the data scientists, because to really get the value out of this data, certainly we can do some analytics across it. But when we start getting into predictive type scenarios and some really deep insights, we're going to need some data scientists. Typically, it's something that we've seen a lot in startups, and this is because, cross-functional agile teams, blurring around the lines of what people's job descriptions are. And this is something that's perhaps not as prevalent in enterprise at the moment. Often people have very defined roles, the teams are quite separate, they're normally under different management structures. So in order to make this really successful, we do need that coming together of skills to work together to really drive value from this platform. So Hadoop and Azure. So like we said, it's an open framework, open source, and you would have heard in the keynote when Scott Guthrie was saying that Microsoft is one of the biggest contributors on the planet to open source now. So within the Hadoop framework, we've been lending our skills, particularly around the data access. So some of the recent improvements like TES and LLAP, Microsoft has been very involved in contributing code to these code bases and giving it back to the community. Beyond that, you can also get commercial distributions off Hadoop. So the commercial distributions often have little nuances. They might write their own pieces of code that sit on top, and they'll often have a free community edition or a licensed edition where you get additional support and additional capability. So within Azure, we have the three major Hadoop distributions, being MapR, Cloudera, and Hortonworks on IaaS. And there's images that you can actually go straight to the marketplace and begin using, type in a few details, click a button, it'll all get provisioned for you. So that's that, removing that necessity to be able to configure the roles of the different nodes, make them talk to each other. Beyond that, we've got our HD Insight PaaS. So this one is kind of the next step beyond that. This is a managed service in the cloud. You don't need to worry about any OS patching, you don't need to worry about any component patching within the Hadoop platform. We do all that for you. So again, you basically click a few buttons, off you go. And within that, we've got different flavors of Hadoop. So at the moment, I think we've got 6 or 7. So regular Hadoop, Storm, Spark for powerful in-memory computation, HBase for NoSQL, and most recently, we've introduced a preview version of Kafka. So where to next? Let's have a look. Okay, so let's start off first of all, just looking at the marketplace and seeing what is available there. Wake up. So I'm not good at talking and clicking at the same time. So, like I said, we've got both Hadoop distributions and also ISV products that interact very closely with Hadoop and can augment some of the capabilities. Things like Datamere is one of those examples. We've also got Hortonworks sandboxes, we've got R edge nodes, and like I said, some MapR and Cloudera components. These images on here have been developed by these vendors. So the MapR, if you choose this has been developed by MapR as one of our independent software vendors and loaded up to the marketplace. Like I said, these ones you can choose from community editions or you can bring your own license. However, today we're really here to talk about HD Insight. So going to do, it takes about 20 minutes to actually fully fire one off, so I'm not going to go through the whole thing, but just show you how quick and easy it is to do. There's really kind of 2 pages where you've got to put information, mainly your name, where you want to put it, some passwords and things, and the other is the storage account. And from there, it's really just click next and then wait about 20 minutes, and then you've got a working Hadoop cluster. Once you've done that, why have I got 2 things the same? I'll just go back to one that I've created earlier. This is where you're able to interact with the cluster you've just built. You've got options around scaling, which you can do from the portal, and a bit later we'll talk about all the scripting options that you can use there, and link out to the configuration dashboard. And this is really the, I guess, the flight deck of your Hadoop cluster. You can have a look at the usage, how much CPU you're using, how much RAM, and inform your decisions about whether or not you need to start scaling. You can also go in and start to change configuration parameters. So even if this is a PaaS service, unlike a lot of PaaS services where you don't really have much access to the configuration of the product, this one you can actually go in and, I guess, interact with it quite deeply. You can change the memory settings, how much memory you want to allocate to each query. You can start setting up resource queues, so you can start isolating different workloads. And you can also start deploying your own bespoke pieces of code. So you might actually choose to have a, well actually there's an example that I used recently. We needed a later version of Java than the one that was deployed on the cluster. And so what you can actually do is, on build time, deploy extra pieces of code that get pushed out to every node. And this is just through a script action that you basically, it's 4 lines of code where I'm going and getting in this case, a JDBC driver. It could be a jar that I've written that knows how to process a specific file type. And I can push that out onto every node. As I scale, this piece of code will go onto all the new nodes. And I can also store this in my scripts. So when I start building new clusters, these pieces of information that I'm starting to build up, this IP around how I need my clusters to look, can get deployed exactly how I want it every single time.
So taking the conversation back into the enterprise, and as Erica mentioned, it's a platform as a service. And that's what we're focusing on today, and the capabilities that platform as a service offer. Just to reiterate, you know, the capabilities required around skill set to build out infrastructure as a service or build out on-prem deployments, there's a certain skill set that's required. And that's a barrier into the enterprise. But that's not the only barrier into the enterprise, and security seems to be one of the things that always pops up as a blocker. And we've had several conversations with chief security officers or chief information security officers, risk management teams, those sort of things about, well, you're actually putting a lot of our data into the cloud. How do you protect that? And there's a lot of questions around the capabilities of security, particularly when it comes to PaaS. So as infrastructure as a service, you've got quite a few options because you can play with firewalls, you can play with you know, locking down the host and those sort of things, and you've got the flexibility there. In PaaS, you're somewhat restricted with what you can do. I guess the benefit of HD Insight, it's a little bit of both. So it's a little bit of IaaS and it's a little bit of PaaS. You get the benefits of PaaS because you can spin up a large workload and scale it and do all sorts of things really quickly. And it delivers a platform, that platform being a big data platform. But on the other side of the things, as Erica mentioned, it behaves a lot like IaaS. You've got a lot of flexibility about what you can do once that platform's up and running. So it's sort of the best of both worlds. Best of all, you pay for what you use. So taking the security conversation a little bit further, how do you actually manage the data that you're going to be putting into the cloud? How do you protect it? And what do you do? So we're going to walk through some examples today of what we've done with some large enterprises and how we've made recommendations from our observations and our learnings on how to best manage the security around Hadoop. So looking at perimeter security and working through the configuration of the platform, how do you best apply roles-based access to the configuration of the platform? How do you restrict access to who's scaling it up, who's deleting it, who's got access to certain things within the platform? Looking at private networks, how do you make it look and feel like it's on-prem? How do you secure access to it from a network perspective? Access and auditing. So security teams and architects are always interested in who's accessing it. How do I know who's accessing it? So we'll talk a little bit about how it integrates with your corporate directory via Azure Active Directory, and more specifically, Azure Active Directory directory services, which is a bit of a mouthful. But needless to say, you can integrate it into your corporate directory. You can then start to go through audit logs. You can start to do access and authorization based on named users. No more generic accounts. So you've got that capability to extend that into an enterprise and start to see who's running queries. And Erica will run through a demo where she actually walks through how you might mask data or provide different types of representation based on a user. There's also the log management associated with that. I think I've talked that to death. Data protection and integrity. So how do you actually manage the data once it's up in the cloud? How do you provide separation of data? How do you protect access to the data? So I'll talk a bit about shared access signatures, or SAS keys, which is effectively a certificate or token that's given out to people to restrict the access of what they can and what they can't do. And also, natively, you've got encryption at rest. So talking about roles and service administration, I'll try and make it clear that there's two different types of service administration in the cloud. There's the platform itself, so the shell, for example, and the console, and having access to the console and the roles within the console. But there's the portal as well, and the portal has quite a lot of configuration items in it. So service administration is the access to be able to do things within the portal. And the diagram that you can see there, you can allocate to users, groups, or even applications. You can provide those three entities entitlements and abilities to do things with the service. Then looking at resource groups and the resources within the resource group. So if you're not already aware, resource group is just a logical container. From the experience that we've had, bundle all your resources into the resource group. Manage the resources as a resource group, and then apply management to the resource group. So you apply your RBAC to the resource group, blow away the resource group, provision as a resource group, and you provision the resources as a unit. So there's different roles in there, and that's sensible because it allows for separation of duties. So for example, you don't want your service desk administrator to be able to go in, modify any of the configuration items around the platform, but you may want them to be able to go in, have a look, and see, is the service running? Has it been stopped? Is there an error in the portal linked to that resource group? There's contributors. So they're people that are allowed to make modifications to those configuration items, but they're not allowed to add any more users. There's readers. So I've talked about those with service desk people, and obviously owners. So they have full entitlements to do whatever they like with those resources. I've already talked about access control about the actual HDI platform. So within the portal, and what you do in the portal, that doesn't apply the entitlements to the HDI platform, the worker nodes, the head nodes, those sort of things. So that's where you'll be starting to use other tools that Eric will do a demo on in a second. PowerShell is probably going to be the biggest skill that your organisation is going to need to develop, because a lot of the stuff that provides extended capability is all done through PowerShell. So PowerShell is how you get the access logs. PowerShell to access storage accounts, to pull down the event logs and security logs, those sort of things. That's going to be a mandatory requirement that your organisation is going to need to develop. So don't think that everything's done through the portal. Everything can be automated and orchestrated through PowerShell, and PowerShell is where you get your extended capability from. So then talking about network access, how do you make it look and feel like it's in its own VNet as a logical extension of your on-premise network? So out of the box, when you go in to deploy Hadoop, the default option is just to deploy Hadoop in its own isolated VNet that's available on public endpoints. But one option in there is to deploy to a dedicated VNet. So you can provision a VNet that's part of your IP address range, and you would extend that connection between your data center and Azure with ExpressRoute. So it appears as another VNet or a subnet sitting on your corporate network. You then deploy HDI into that VNet, and it just appears as nodes bubbling up within your VNet on your network in your corporate IP address range. Network security groups, or NSGs, are a layer 3, layer 4 component within Azure that allows you to apply network filtering. So you can now start to restrict the access to Hadoop from a network perspective. You can start to put it in its own little environment, enclave it off, and protect it from other environments. Control the access that you've got to trusted hosts, trusted devices. ExpressRoute for organisations and enterprises is one of the key things that allows you to manage that traffic and deliver it over a private, secure network. It doesn't pump everything out through the internet. So with the ExpressRoute public peer path and ExpressRoute private peer path, all of that traffic is managed through a virtual circuit directly into Azure. And lastly, load balancers and nodes. So we talked about platform as a service. It's not only the compute environment, but it's also the networking environment. So if you know and you'd be familiar with managing clusters, as you start to scale up with the cluster, you need to then manage the load balancer, you need to manage all the rules that are associated with that. Azure manages that for you. So all you do is tell it how big do you want your cluster to be. So it manages things on your behalf, which minimizes human intervention. And as you start to get humans involved in making firewall changes and load balancer rules, that's when mistakes occur. So from a platform as a service perspective, the reliability and the integrity of Hadoop as a platform is managed for you on your behalf as a platform. The last thing is data storage access. So storage access is storage accounts within Azure and the ability to be able to manage those. And there's a couple of different perspectives with regards to storage accounts. So the first one is separation of data. And what I mean by that is you may not want all of the data to be available to everyone within the organisation. So looking at it from a business perspective, the output produced from your big data transform, you might want to separate that up into different departments. So you provide different storage accounts for the outputs. So for example, you might have finance data, you might have retail data, you might have customer data. But the purpose of doing that is to separate the data and separate sensitive data out from general data and then manage that sensitive data differently to what you would manage general data. The other component to separating data storage is development and test systems. So for example, you would set up your inbound or your landing zone of raw data as a read-only repository. You don't want your big data systems going into your landing data or your landing zone and transforming that data and screwing around with it and messing it up for other transforms or other big data processing systems. So when you've got a landing zone of data, that's read-only. Different storage accounts for your outputs, but also for your dev test systems. So you might have your dev test systems reading from that landing zone. And they can, multiple Hadoop platforms can be configured to access that landing zone and draw down on that data to provide you with integrity around your dev test. The other thing is the shared access signatures. So as I mentioned before, they're just like a certificate. And if you're familiar with storage accounts have a primary key, secondary key, storage account, and that's about it. But with a SaaS key, you can go a little bit further. SaaS key, you can actually lock it down to an IP address. You can lock it down to a specific time. You can provide restrictions on actions, such as read-only, read-write, and you can even label containers. So you can limit it down to a somewhat granular level with the SaaS key. So if you're not familiar with SaaS keys, I thoroughly recommend that you start to have a look at what capabilities are available in a SaaS key, and particularly with your storage accounts, start planning to use SaaS keys, because that's been one of the biggest bones of contention with a couple of our customers in large organisations, is how do you manage data once it's in a storage account? So have a look at SaaS keys, and encryption at rest is a tick box turn on, and that's all done for you.
Great. From there, as we mentioned, is identity. So Azure AD, we can now integrate domain join our clusters, and this is quite a recent feature, currently available on the Hadoop cluster, and will soon be rolled out to other flavours of Hadoop, like Spark. So what this means is now we got our Azure AD identity, which can be synced from our on-prem, and we start to get some of those capabilities like single sign-on, MFA, and we can actually synchronise that through to our HD Insight cluster via Azure AD DS. Right number of A's and D's. And basically what that means is this via LDAP pushes across users and groups that we choose to synchronise to our cluster, and via the Ranger product, we can actually start now defining access control rules around our HDI cluster. So I can give groups access to the different data, I can have my finance team, I can have my marketing team, give them different access, and I can also start doing other tricky things like masking policies. So I might have a particular group of users who can see the data that has credit card details. They might have all the numbers. I can start applying masking policies, so different groups might see the first 4 digits or the last 4 digits, but not the entire piece of information. And I can also start putting filtering rules around it. So I might have geo data, and I might have my Singapore users, and I want them to only be able to see Singapore data. I want my New Zealand users to be able to see New Zealand data. And then I've got a corporate team who maybe needs to see that cross view of all the data. And this is all done via Ranger. And I can also audit. So I can see failed logins, I can see who's actually been creating and modifying policies, and I can see people who've trying to access data they're not perhaps supposed to, and I can actually pump this data out to a security system where we can start analysing and acting on that in a more automated fashion. And from there, let's have a look at Ranger. So this is my HDI cluster, which I've domain joined. So first of all, what will be different about this kind of cluster compared to a more basic one is I'll actually have my domain configuration options. So I've created my own Azure AD specifically for this event, and I've created a group called Hive Users. And so as I go to build my cluster, this is where I define which groups I want to synchronize across to my HD Insight, because I don't specifically want the entire organization having access to this. From there, the Ranger tab takes you actually into the portal where we can actually start looking at some policies. So I've created 2 policies. The first one I've done for Hive User 1. Like I said, we can do this via groups, but I've, just for the purposes of demo, doing it via specific users. And on the Hive sample table, on all columns, I'm giving Hive User 1 select access. So if I jump in and just do a really simple query, I'd expect as Hive User 1 that I'm going to be able to see all the data in this table. And once my tiny, tiny cluster finishes doing this, we'll see here. So 10 rows and all of the columns. For Hive User 2 though, I've created a different policy. I've only given them access to 3 columns. So now, if I jump across, firstly as Hive User 2, if I actually try and query all of the columns, I'm going to get an error. So I don't have access to just select all, I need to actually specify which columns. So when this comes back, very shortly, So yeah, permission denied, I don't have access to all the columns. So again, as the administrator, when something like that's happened, I can look in the audit and see Hive user 2 has failed because they didn't have access to all the columns. So we'll just change this again. So, sorry, double check which columns I did give it access to. I think for client ID. Device make and device platform. Again. And this time I expect this to be successful. But you'll notice the device platform data is actually quite different than what I got when I was running as Hive user 1. This is because I've actually created a masking policy across this user. So that's the next tab, masking. We can go in here and I can edit this policy. So there's quite a lot of pre-configured options, or I can actually create my own custom option if I've got specific data to my organisation, and that's just like a regular expression where I can start to build up my own. So I might just change this one to a partial mask and save that. And again, I've mentioned that this stuff all gets audited. So if people are in changing policies, I can actually see that people have started modifying. So this person here, me, I've just changed the mask from a hash to a partial mask. If I run this again, I expect that the data is going to come partially masked this time. There we go.
So I guess that brings us to operating in an enterprise. So I've talked about a couple of things such as what big data is, how it helps an organisation, what capabilities it offers. We've talked about securing it. We've talked about how to associate users with your corporate directory, being able to restrict and manage data, those sort of things. How do you operate it? So we've talked about the build components. How do you operate it? How does it become part of an organisation in terms of standard operations? And as Erica mentioned, typically we've seen this operate in startups, and it's got that startup mentality around it. And one of the challenges that we've observed is that there's a perception that big data and clusters and all of these different types of storage accounts and those sort of things, it's complex and it's difficult. And one of the things that we want to walk through today is provide you with examples of what we've done with our customers and what we've seen that works. So we want to talk you through some of the things that you need to think about in terms of your planning and in terms of your deployment that's going to help you get operational within an enterprise. So the first thing that we want to talk about is automated deployment. Without automated deployment, it is complex, it is difficult, but with automated deployment, it simplifies things quite extensively. And it's one of the things that we want to emphasise on. Automated deployment and scripting and managing that as infrastructure as code is the key thing to making this work for you. We'll talk a little bit about configuration management and how to work through configuration management and what to do in terms of configuring, scaling, those sort of things. Give a couple of examples of scripts, ARM templates, those sort of things. Talk about the integration with test dev lifecycle and how to then manage test dev lifecycles, those sort of things, how to run through product updates, those sort of things, and talk about lifecycle maintenance. Start to look at data backup and retention. So once you've got all this data in there, how do you back it up? How do you preserve it? How do you maintain it? And then business as usual. So job submission, scaling, monitoring, and the user experience.
So this is where the real fun begins. We've got scripted builds, we have our HD Insight templated out, all our post configuration is scriptable, and this means we can start to automate things. So test and dev. Basically, we put all this code into our code repository, it might be in GitHub, and we can build it into our existing processes. You can develop in whatever IDE is comfortable for you. So you can use Visual Studio, but like I said, a lot of this stuff is Java-based, so you might prefer to use something like Eclipse or IntelliJ. Start developing your code, check it into your source control, and start looking at automation options. So I might start building on a schedule or basically on check-in. And this means I don't need to have a test or dev or multiple test and dev environments running constantly. Basically, from the time this gets triggered, builds the HDI, runs the post config, starts to run all my test scenarios, collects my output, and then shuts it down. So I'm only paying for test and dev in this scenario whilst I'm actually running my automated build. Beyond that, obviously you're going to have test and dev environments that you probably won't want up running all the time. However, again, you can actually take your production templates, it's all parameterized, so you can spin up as many as you like based exactly on your production environment. And building upon what Aaron mentioned earlier, I can actually start using the same source data. So I can give read-only access to some of this data that's been generated by my production cluster. So I don't need to start duplicating my data across the environment. I can, what else do I want to talk about? I can, help me out here. No, I've forgotten.
Move on.
No.
So talking about...
That's it. It was the scaling also. Automated scaling. So I can, with my test and dev environments, also choose to delete them overnight, or I can scale them. So one of my customers recently, they've got multiple dev and test clusters running, and at this point in time, they're not fully templated, but what they can do is they can automate every night, scaling down to just one node. So from that, we can take it to like a quarter of the price. So you start to get the benefit of the elasticity of the cloud.
So talking a little bit about maintenance, and I mentioned earlier around infrastructure as code. Consider HDI as a disposable platform. It doesn't persist, it doesn't hang around. You don't water it and feed it and maintain it. It's completely disposable. And just re-emphasising Erica's point, in a test dev lifecycle, you may only want to run it for a period of time to run a transform and then terminate it. So during that period, what do you do with all your configuration items? How do you make sure that you can spin this up in a consistent manner, repeatedly go through the process and have a consistent outcome? The key to it is externalizing everything. So externalize your templates, manage them in a source repository, be it GitHub, Visual Studio, whatever. But manage your templates as if they are source code for an app. Manage scripts as if they are source code for an app. And manage it in a source repository so you can keep track of different versions of scripts, which one's for production, which one's for dev, which one's a work in progress, and manage all of those outside of the Hadoop environment. Because Hadoop is disposable, you don't want to put anything into it. Anything of value that you put into it is going to be tossed away. So externalize it. To update a cluster, say version update comes along, or product update, or patch, or whatever it is, redeploy it. Don't bother about patching it. Don't bother about fixing it. Just redeploy it. You've got source code here, run a script, introduce the template, redeploy it. With regards to backup, you can actually externalize the metastores. So all of the Hive tables, you can put in a SQL database. So again, it's not part of the Hadoop platform. It's outside, it's in a SQL database. So to back up the data that you've already structured and queried and processed, you can start to back that up with SQL database and use Azure's in-cloud backup service. There's also a Azure function to run in Azure Automation, which will do backups of your blob storage. So we've got, I think we've got a link to that in a couple of the last slides, but there's an Azure function there available to start backing up your blob storage for the processed output and also the ingested data. The other option that you've got, rebuild from source. You might have so much data that you don't want to back it up. It's easier for you to rebuild from source than to transform and produce reconsistency again. So you've got a couple of options there on fault tolerance or recovering from catastrophic loss. So through this slide, we're going to build up what it looks like to redeploy HD Insight. So the first thing is you configure HDI and you externalize your metastore, externalize your storage. You bootstrap a new HDI cluster. And you bootstrap this from ARM templates, scripts, whatever you like. You then connect it to the externalized metastore and storage blobs, and you run some testing. Make sure it all works before you destroy the old cluster. And you can do this because remember we talked about attaching HDI to multiple storage accounts, multi-attached to the SQL metastores, and then destroy the old cluster. Your big data platform has just been updated. It takes about half an hour. And that excludes testing, of course, but let's say you've got a test harness, run that through a test cycle. Worst case scenario, 45 minutes. And you've rebuilt your big data platform.
So where to from here? There's so many bits and pieces we'd really like to cover. And so what we're going to do is actually call out some other sessions. Some of these may have actually already passed, but we do recommend that you check them out on Ignite TV and you'd be able to download the decks and have a look at them. But one of the things is about job orchestration. So within HDI, you've got Oozie for scheduling and you can externalize your Oozie metastore. You've got APIs, so you've got REST APIs that you can call out for job submission. So you might already have a scheduling, you might be using Control-M, you can integrate the tools that you're already using via API calls, kick off jobs, schedule your tasks, and control your environment. Something else we have, another PaaS service, Data Factory. So we actually offer HDI on demand. So basically, as part of your data pipeline, it'll fire up a HDI instance, run the processing that you've defined, shut it down again, and you only pay for what you use. So I recommend you look at the Data Factory HDI on demand chat. The other one is around logs. So like we said, you need to be capturing the logs. There's multiple components inside Hadoop that is generating output. So you'll have your yarn logs, you'll have your TES logs, you'll have MapReduce logs. You're able to capture all of these. They go to storage accounts. You can feed them into log analytics by OMS and actually integrate that with your existing organizational monitoring. Also mentioned data scientists. So we can have edge nodes, and our edge node allows the data scientist to run multi-threaded R code against your big data platform and start to really derive that value from the big data. And then your business analysts, they can actually report directly from Power BI. We have connectors for Spark and Hadoop, so these people can actually start just reading this data, start visualizing the data, and actually getting some real value, and that's straight away. Then the other thing is we also mentioned data warehouse. So a big data platform doesn't get rid of a data warehouse. It's a different lens on the data. So we've got Polybase, which actually allows your SQL data warehouse to hook out to the data in your Hadoop cluster. This means that we can get the raw data, transform it, get it into a format that's more business ready, and then read this straight into the data warehouse. And vice versa, rather than keeping all your data into a premium product like Data Warehouse, which is on premium storage, as data ages, you can push it back out, store it in your Hadoop cluster. It's there whenever you need it, but you don't have to keep all your data in the one place.
Thanks, Erica. So what I want to do now is show you a quick demo with regards to what you can do with a couple of ARM templates and some PowerShell. So I'll walk you quickly through an ARM template that I've got here that I've built for the Ignite demo. But what I want to show you is it's really easy to get started. And the reason why it's easy, we've helped you build the template. There are templates available to download, to play with, to do whatever you like. So jump on the Azure Docs website and you'll be able to find these templates as an example. But here's one, and I want to show you two templates and the difference between the two templates and how they might be used in your organisation. So if you're prototyping and you don't have different environment variables or different parameters, and you want something that you can just deploy, tear down, those sort of things, this is an ARM template that has the virtual network within it. So I mentioned earlier, you can deploy HDI into its own virtual network. So this example has a virtual network. This is the ARM syntax and construct for a virtual network. It goes through, creates a virtual network, creates a subnet, and then it goes through and creates the cluster. So you can start to see here, it's relatively easy to understand too. It's not something where you need to be an app dev to understand what it is. It's relatively straightforward and it's in somewhat English terms. So you can go through, create your cluster. There's the components of the cluster being the head node. You can see the count there, so you can scale up, scale down as you need to, or what is recommended for your organisation. Worker nodes, so on and so on. And also the storage account. So within this one template, network, Hadoop cluster, storage account, all in one go. The other option is you might actually pass out two parameters. So you've got a template, which is your standard construct, but you've got variables that influence that. So that might consist of your test, dev, and production environment. So showing you the parameters file, I can actually use the same template, but deploy different environments based on parameters. So this is the power of ARM and the power of scripting with Azure Resource Management. So what I want to show you is very quickly how easy it is. So you can see here I've only got 3 resource groups. None of them are distinguishable as an Ignite resource group. And I've got some PowerShell. And this PowerShell has been generated through a PowerShell generator that's available in Azure. So I'm not sure if you've noticed, but when you're deploying something, there's an option for automation options. If you click on automation options, you get the ability to generate PowerShell and also generate ARM templates. So we make it really easy for you to do this. You don't need to do it from scratch. So this pulls in 2 things, the template file, parameters file, logs into Azure, and then deploys it. So 100 lines of code looks like a lot, but there's quite a few conditional statements in there. So I'm pretty sure you could get that right down if you wanted to. And I've sort of preloaded this, ready to go. So I've got one line to kick this off. And I kick this off, I log in, and that's off. And that's going to take about half an hour to build. And I can kick that one off as well. And hopefully, what I'll be able to show you is it appearing in here. So as it starts to build out, it goes through, and it doesn't give you much feedback because what it's going off and doing, it's taking that ARM template and it's going to do it in sequence based on what that ARM template requires. So it'll go off, start provisioning. That's the only downside of PowerShell. It doesn't give you the feedback as to its progress and what it's done because it deploys it as a resource group. And remember at the start of the presentation, talked about deploying resources as part of a group. So it's deploying a resource group with a bunch of resources, all as one unit. So if I just refresh this, you'll see it's created 2 resource groups. Within those 2 resource groups, it's starting to build things out. So it's built my network. In about 5 minutes' time, you'll start to see all the worker nodes, zookeeper nodes, and all the other nodes appear. So I've used one command line and a repeatable usage PowerShell script, repeatable template to build out my environment. Now that'll go out, that'll take around about 30 minutes to build, but that's how easy and that's how quick it is. So I'm not sure if you've got any other examples where you're able to build big data solutions so quickly, but that's the advantage of Azure, and that's the advantage of PaaS. Now I haven't got an administrator that's built out that environment for me. I haven't relied on system engineers to go and build a network, punch a hole in a firewall, manage load balancers, and all the change requests associated with it. I mean, if you think about it, you've got this repeatable process that's always producing a consistent outcome, becomes a standard change. That's the power of ARM, that's the power of Azure, and that's the bonus that you've got of using our cloud. So I'll just flick back to the slides. Oop, gone the wrong way.
So that's probably about it. That's all we've got time for today. So just to recap what we've gone through, we looked at the capabilities, why we'd use Hadoop, what advantage we've got with using big data in the enterprise, how do we actually secure it, and all those different layers. And it really is a defense in depth type of security discussion. And that is what we're having with a lot of our customers. It's not one item, it's not one checkbox, it's layer upon layer of security that we're applying to the environment and the integration. And then finally, the enterprise. We've talked, I guess, very briefly about some of these things, about how we monitor it, how we could scale it, how we could enable auto builds and ARM templates, and to make a really repeatable process. How we can share data between clusters and actually empower us to do things like have perhaps a regular Hadoop cluster that was servicing our BI requirements, and maybe we could fire up a separate Spark cluster on a schedule and actually, on the weekend process the really grunty stuff, blow it away again at the end of the weekend. They're disposable, we don't care. We only care about the data, that's the asset. The compute is just the muscle. And I think we've got a couple of bit of housekeeping slides to do, and this one here, and this will be available in the deck for download, but here's just a couple of links of where to go to for next. Obviously there's lots of documentation, lots of examples, and a lot of these also link out to GitHub, where a lot of this code has already been written and pre-prepared, and you can go into Git, download it today, and actually start building out your own. And the learning map is really fantastic, so that actually takes you through, I guess, step by step, how to deploy a cluster, both from the basic method where we go into the portal and start click, 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 and also then right through to how do we actually template and get a bit more repeatable around it. And also a lot about, when would I use Spark? When would I use HBase? Like, unfortunately, we just don't have time to go into all the different ones and really deep dive into them today. There's also lots of free training available on Microsoft Virtual Academy and lots of videos on our Channel 9 streaming site. From there, obviously, there's still time to win a After Dark drone experience for tonight's party. I've heard a rumour that the higher you rate the session, the more likely you are to win. So I'm not sure if that's true or not, but I think you should just be safe, better safe than sorry. And also, don't forget to get your tickets, and that's somewhere. And finally, there's our contact details. Now, I've got a confession. I got a little bit carried away with all the double letters. We've fixed it up on this one. But if you do actually end up downloading the slides, and you'll discover that Aaron Morrison has an extra S in it, he's blaming me. I think it's more just so that you can't contact him, but it's only one S in Morrison. So with that, we'd like to invite any questions. Yes?
With all the maintaining logs, can you download them to your premise, or are they always stuck in the Azure cloud?
So the question was, with all of the event logs, system logs, can you download those logs and maintain them on premise, or do they stay up in Azure? So they're available in a storage account, so you can certainly download them. We've got a couple of customers that are actually using SIEM or SELM solutions to integrate those into their security environment, so they've got real-time logging and alerting. So those logs are available to be streamed down. There's also a security log analytics integration feature in Azure. So that was in public preview, I think, a couple of months ago. So that's something that you might want to look at. Any other questions? Yeah, sure.
Sorry, so I think the question was with data ingest, what method would we use? Yeah. I guess that's the thing with Azure, there's so many different options. So often we're working on a kind of Lambda architecture where we've got a real-time and a batch process. So from the batch process, often we're looking at things like Data Factory, and with a data management gateway, you can reach out onto on-prem and bring files up into Azure. Otherwise, you can do a push. So if you don't want to have Azure controlling it and pulling the data in, you might push the data. So you can use AZ copy to actually just push the data up into storage accounts because they're just files. So it's literally just a file copy. From the streaming component, we've got integration with event hubs and stream analytics. So that's one method to get it in. There's also a Storm cluster, which is another streaming option. And Kafka, which is our new complex event processor. So Kafka's more, I guess, the equivalent of event hubs, but in a much more scalable and much more configurable manner. So that's an option that we've got at the moment as well. But like I said, because it's just files, really there's any way you can push it in. And then also you can kind of hook in through things like Scoop. So, I mean, the capabilities are limitless, really.
So the question was, you can have multiple data types, be it CSV, Excel, SQL. And I think that's one of the bonuses of a big data solution is it can be anything. So we talked about pictures. It can be pictures, it can be text. So TXT files, could be a Word document. It could be Excel, could be structured, unstructured, no matter what format it is, SQL, Oracle, whatever database you like. If you can pump it out to a storage account or pump it out to a structured format, that becomes your raw data source to be ingested. And then obviously you apply a transform and then produce the preferred structured output that you want to create. Does that answer the question? Great.
Anyone else?
Okay. Thanks very much.
Great, thank you very much for coming.